Hello everyone, hope you all are doing well. In this video, we will be discussing about chemical kinetics, a chapter from chemistry class 12th. Some important questions we will be discussing in this video. The first question goes as, for a chemical reaction, N2 plus 3H2 gives 2 ammonia, the correct option is. Now, in this question, we have to find the rate of the reaction. So, to solve this question, we need to know about two things about rate. First thing is that rate is always positive and rate is given for 1 mole of reactant. Now, to solve this question, as we all know, you should know that rate is change in concentration per unit time. For concentration, we use this box brackets. So as we said that rate should always be positive. So, in case of reactant, here the reactant is N2 and H2. For reactant, concentration decreases with time. So, that is why in rate equation we use negative sign in front of reactant, and in case of product, as concentration is increasing, so the change in concentration is always positive. So, we use positive sign. So, and also the second part of the of rate equation is it should be always given in 1 mole of reactant. That is the reason we will be dividing it with the coefficient, stoichiometric coefficient of the reactant. So, the rate equation is given in this way. Rate is equals to minus of dN2 by dt is equals to minus of 1 by 3 dH2 by dt is equal to plus of 1 by 2 d of NH3 by dt. We will be matching answer number 4, like the option D is correctly matches with this equation. So, correcting this option. The second question goes like this: for a reaction of order n, the unit of rate constant is. Now, to know about the unit of rate constant, first we have to know what is the formula of rate. Rate is given in the form of K, concentration of C to the power n. Then what is K? K is the rate constant. Here C is the concentration and n, which is given as a power, is denoted by the order of the reaction. The unit of concentration is generally taken in mole per liter. Now, second definition for rate says that rate is equal to concentration per unit time, change in concentration per unit time. So, here concentration, the unit of concentration is given as mole per liter and unit of time is taken as second. So, the unit of rate is given as mole per liter per second. Now, putting the unit of rate and the unit of concentration in the above formula, we can solve it and we will directly get the answer. Like I have solved it, you can see it goes like mole per liter per second upon mole per liter to the power n, and on solving it we will directly get, it is general max equation that we can solve, and on solving it we can get the rate constant SI unit. So, the option which matches is option number C. Okay. So, moving on to the next question. The question says A plus 2B gives C. The rate equation for this reaction is given as rate is equals to K, concentration of A into concentration of B. If the concentration of A is kept same but the concentration of B is doubled, what will happen to the rate itself? So, for solving this question you need to know some points. The points goes like that. I have made a table for explanation, easy explanation here. Order of reaction, concentration and rate. Now, if you can see, in case of zero order reaction, the rate law equation says like this: rate is equals to K, concentration of C raised to power 0, because the order of reaction is 0. That is why we can say for zero order reaction, rate does not depend upon the concentration of reactant. While in case of first order, it is raised to the power 1, concentration raised to the power 1. And for second order reaction, it goes like rate is equals to rate constant into concentration square. So, using this equation, we can directly say that in case of zero order, since rate does not depend upon the concentration of reactant, therefore, if we will double the concentration of reactant or triple the concentration of reactant, rate will not change, rate will remain same. But in case of first order reaction, we can say like if we will double the concentration, then rate will also double. If we will triple the concentration of the reactant, then rate will also triple. But in case of second order reaction, we can say like if we double the concentration of the reactant, it will square. It will be square of the concentration. So, if we will double the concentration, then rate will be 4 times. If we will triple the concentration, rate will be 9 times. Similarly, if we will be doing 4 times the concentration, then the rate will be 16 times increased. So, the above equation was rate. I have denoted it by R1. The rate was given by K, concentration of A into concentration of B. And the question says if we will double the concentration of B and the concentration of A will remain same. So, what will happen if we will double the concentration of B, since the order of reaction with respect to B is first order reaction, therefore, the new rate which will be formed will also be doubled. You can see in this explanation which I have written here. Moving on to the next question. The question says when initial concentration of the reactant is doubled, the half-life period of a zero order reaction is. Now, to know about the half-life period, we need to know what is half-life time. Half-life time is if like I have written a reaction in this way, A is converted into B. Now, at time t is equals to 0, when reaction is not started, I have taken a beaker, I have added A into that. The concentration of A is, for example, this small a, I have denoted it from small a. Now, at time t half, half lifetime I have denoted by t half. Now, t half is the time when half of the reactant is converted into product. Now, if half of the reactant is converted into product, then how much product will be formed? Half of the, it will be equal to the concentration equal to half of the reactant, matlab B की concentration is equals to A by 2 and similarly A की concentration B is equals to A by 2. Okay. So, for this we have given a general formula to identify how we can relate half lifetime with the initial concentration of the reactant. So, we have given a formula which directly relates half lifetime with the initial concentration of the reactant. The formula says like this: half lifetime is inversely proportional to concentration of reactant to the power n minus 1, where n is the order of reaction. Now, you have to note one point: this formula is not valid for first order reaction. It is valid for all order reactions except first order reaction. So, if we will put the value of n as 0, we will find that t half, that is half lifetime, is directly proportional, becomes directly proportional to concentration of reactant. So, if we will double the concentration of reactant, then t half will also get doubled. So, using this we can mark our answer option number B. That is all for today. Thank you everybody. Thanks for giving your precious time to me. Have a good day.